All right, good morning, everybody. Today we're going to finish up chapter 7 by talking about chapter 7, section 5, real numbers. What are real numbers? Real numbers, when we talk about real numbers, it's the group of all numbers that can be written as a decimal and satisfies the following conditions. These conditions I'm talking about here are going to be the derivation of all of the real numbers. So the symbol looks like a real estate agent. That means real numbers. Real numbers are broken down into two groups. S is denoted as the irrational numbers, and Q denotes the rational numbers. Like, remember, rational numbers are fractions whose decimals either end or repeat. Irrational numbers are not rational, meaning they don't end, they don't repeat. Or repeat. Kind of like I and E. Those are numbers that never end, never repeat. So real numbers are broken down to rationals and irrationals. Now, under rationals, you have the I, which stands for the integers. Remember, integers are all the negative numbers, 0, and all the positive numbers, from negative infinity to positive infinity. Those came from the group of whole numbers. Whole numbers start with 0 and go to infinity. And lastly, we have the natural numbers, or the counting numbers. Start with 1, 2, 3, and go on to infinity. So those are the groups. In other words, we first learned the counting numbers, the natural numbers. Then we added 0, we got the whole numbers, and went to integers. Now, from there, once we have all those, we could put them in fraction form. If the fraction repeats, has a decimal that repeats or ends, then it's called a rational. If it doesn't repeat or end, it's irrational. And together, all those make up the rational numbers. All right. Let's look where they came from. For an example of them. Square roots and the principal square root. The square roots and the principal square root. Square roots are denoted by that symbol. The reason that's called square root, which we're going to talk about, do some examples later, probably jump into it now, is because the number inside here in that little v is called a root. If it's square, there's an invisible 2 there. So if there's nothing there, it's invisible 2. Anything higher has to have that number in it. It just goes all the way down to something called the nth root. This is called the 4th root, the 3rd root, or cube root. Because there's a 3 there. And this is called the square root because there's a 2, or there's invisible, it's nothing there. All right. So let's define square roots. Definition of square root. Right, so it's any number non-negative that any number, it's not a negative number, that has a non-negative number times itself equals the first. So, for example, 4. The square root of 4 is 2. Because 2 times 2 equals 4. The square root of 9 is 3. Because 3 times 3, so this number times itself, as that says, equals that. And that's why it's called square root. This number here tells us how many times does a number have to multiply to itself to equal that one. So if I had the cube root of 8, is saying what number times itself 3 times equals 8. Well, we do it, let's factor out 8. So it's made up of 4 times 2. 4 is made up of 2 times 2. So 8 is made up of 2 times 2 times 2. Since it happens 3 times, the answer is 2. All right. So we say that 2 is the principal square root of 4. Principal square root of 4. Or in this case, 2 is the principal cube root of 8 because it happened 3 times. So square root of 4 equals 2. 2 is the principal square root. Graphically, what this means. So if we have the number 4, we have a square because we're going to take a square root of it. If we have a square, can we make it into 4 equal sides or 4 equal parts? If so, then if both sides are the same, then that's what it equals. I guess square root of 9, the same thing. Okay, so we have a square. Can we make it into 9 equal pieces? 9. Yes. So this side's 3. This side's 3. So the answer is 3. So the square root of 8. Two, 3, 4, 5, 6, 7, 8. Yes, they're 8. But they are not squares. Are all squares. So 8 doesn't have a square root. It has something else, but not a square root. We'd have to figure out, can I look at cube root of 8? So we have 1 cube there, 2 cube, 3 cube, 4 cube, 5 cube, 6, 7, 8. So since this is the back of it, so this is the side. Since all 3 sides of this cube are 2 units long, and they have 1, 2, 3, 4, 5, 6, 7, 8, they have 8 pieces, and the cube root of 8 is 2. What is the square root of 144? Or let's try 36. What's the square root of 36? Well, do we have we know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So the square root of 36 is 6. We're looking at 2 numbers that are equal that fit between there. That isn't there. So this is the same as 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Let's look at some other numbers. Square root of 144. We know the square root 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. So the answer is 12. The others. Oh, also works with fractions. If you have a fraction, and this doesn't work out inside here, you can split them up. So what's the square root of 4? 2. Square root of 9, made up of 3's. So the answer is 2 over 3. So how do we use square root? So what if x squared equals 16? The rule is this. The square root of x squared, since this is a square and that's 2, they cancel each other out. The cube root of x cubed cancel each other out. The nth root of x to the power n cancel each other out. So the exponent can be on the outside too. Like this. As long as the root and the exponent inside there, they're the same. As long as the root and the exponent, if they're equal. This is cube. Sorry. If the root and the exponent, if they're the same, they cancel each other out. Same thing here. If the root and the exponent are the same, then they cancel each other out. So in other words, how do we solve for this? Since that's an exponent, we take the square root. Whatever you do to one side, you have to do the other. So square root x squared is x. Square root of 16. We know that 16 is made up of 4 times 4. So it's 4. Those are all rational numbers. Let's look at irrationals. For example, the square root of 2 is usually the first example. Because we know the square root of 1 is 1, because 1 times 1 equals 1. The square root of 4 is 2, because 2 times 2 is 4. And the square root of 9 is 3, because 3 times 3 was 9. But what is that? Square root of 2. Square root of 2 has to be between 1 and 2. Because we know the square root of 1, the square root of 2, square root of 3, and square root of 4. So square root of 1 is 1, square root of 4 is 2. So it has to be somewhere between there, but closer to the square root of 1, or 1. How do we figure this out? We estimate. We know it's big. The number has to be bigger than 1, but less than 2. So let's try it. What's 1.3 times 1.3? 9, 3, 3, 1. 169, 2 decimal places, 1.69. 1.4 times 1.4. 16, 4, 5, 4, 1, 6, 9, 1. 2 decimal places. 1.96. It's getting closer to 2 inside there. What's 1.5 times 1.5? 5 times 5 is 25. 5, 6, 7. 5 and 1. 2.25. So that's too big. So it's got to be close to 1.4. Then we go further. 1.4, 1, and then 1.42. And we keep on getting closer and closer and closer. All right, so 1 times 1 is 1, 4, 1, 4, 16, 5, 1, 4, 1. 1, 8, 8, 9, 1. 1, 2, 3, 4. That's 1.988. 8, 2, 8, 16, 5, 2, 4, 1. 16, 11, 2.0164 or 1.988. This one's closer to 2 because that one's bigger by 9.836. Or too big by 164. This one's only smaller than it by 0.12. So we know that is approximately square root of 2 is approximately 1.41. That's a symbol for approximations. Right? So that's how we look at square roots and cube roots. There's a formula for conversion. Now let me show you why the cube root of x cubed equals x. Because of this rule. Whatever exponent goes on top, whatever's the root goes on the bottom. And they cancel each other out. So we get x to the first, which is just x. So that's how they cancel out. So we have the exponent and you have the root equals the root and the exponent. So if you have that, this is 32. I have 32, so it's 2, 16, 2 and 8, 2 and 4, 2 and 2. So 1, 2, 3, 4, 5. 32 is made up of 2 to the 5th. Using this formula here, the exponent goes on top, divided by the root. The root goes on the bottom. That equals 1. So 2 to the power 1 is 2. So The fifth root of 32 is 2. Let's look at the properties of real numbers. The first one, the closure. Remember the closure property. If you add two real numbers together, will the result, or the sum, since you're adding them, be a real number? The answer, yes. So real numbers are closed. You have the commutative property. Of. It also works if you multiply them. With multiplication. If you take two real numbers and multiply them together, you get a real number. All right, so we have the commutative property of addition. If you have two real numbers, so first I would say X and Y are real numbers. If you have two real numbers, will you get the same thing if you move them around? Yes. 4 plus 2 equals 2 plus 4. They're both real numbers. With multiplication, X times Y equals Y times X. 4 times 2 equals 2 times 4. They both equal 8. The associative properties of addition. Remember, this one is if I have three real numbers and I add them together, they're closed, so they're going to give us a real number, but I can also tell which two to put together first. 2 plus 3 plus 4, 2 plus 3 plus 4. 5 plus 4 equals 2 plus 7. They both equal 9. And also works for multiplication. X times Y times Z equals X, Y times Z. 2, 3 times 4 equals 2, 3 times 4. 2 times 12 equals 24. 6 times 4 equals 24. The identity property. The identity property of addition. A real number, let's see, this is music, plus 0 is itself. 2 plus 0 is 2. Of multiplication, X times 1 is X. 2 times 1 is 2. So that works. The inverse property. Addition. X plus negative x equals 0. 2 plus negative 2 equals 0. Real numbers can be positive and negative, and they can be 0. Multiplication. X times 1 over x equals 1. Two times 1 over 2 equals 1. The distributive property. A times x plus y equals ax plus ay. We learned that we can multiply the two numbers together. A times x, a times y. Since we can multiply them, we can also add them from the previous rules. The answer will be a real number. So those are the properties of real numbers. When ordering real numbers, putting them in an order, for example, if I give you square root of 2 and 1 4/9, they're both real numbers. Put them in order. So which one's bigger? We know. Let's look at the decimal of them. 1.4142, 1356, and so on and so forth. 1 4/9 equals 1.4444. It's forever. They're both equal in the numbers. That number. Here's our first different number. So 1 4/9 is bigger than square root of 2. So on a number line, that's how we order them. Whenever we see the word radicals, that's, for example, the square root, the cube root, the nth root. These represent radicals. As I cut the tabs. Radical equations. Radicals have rational exponents. Radicals have rational exponents. So if we take this, like we just talked about earlier. So this means to be a fraction, a rational exponent. Whatever is in the root always goes on the bottom. And whatever the exponent is, since there's nothing there, it's an invisible 1. Okay, let's see how this works. So what would that equal to? So that would be 4 There's an invisible 2 there, so it's 4 to the power 1/2 because there's a 1 there. But what is 4 made up of? 4 is made up of 2 times 2, which is 2 squared. That's 4. And there's the exponent. The rule is this. If you have a power to a power, you multiply. So 2 over 1 times 1 over 2. 2 times 1 is 2. 1 times 2 is 2. 2 over 2 is 1. So 2 to the first is 2. That's where it comes from. That's how you calculate the square roots if you don't know what it is. So if you had that, how would you write it as a radical? Well, whatever's in the, if you have a fraction exponent, whatever's on the bottom goes in the V. This number and whatever that is goes on top. So it's 5 to radical 3. Okay, so we also talked about the rules of radicals, exponents long time ago. So let's refresh those. Properties of exponents. Whenever you have the same bases, these are the bases, and those are the exponents. Whenever you have the same bases with different or the same exponents, you add the exponents. If you have an exponent raised to an exponent, you multiply. If you have a product of some numbers and letters raised to a power, then everything inside the parentheses gets that exponent. Also works with fractions. You can distribute them. A negative exponent doesn't make the number negative. All it does, because right now this number is over 1, what this says is move this whole number to the bottom, to the other side of the dividing line, and drop the negative. So if I had 3x to the negative 5, only one that's negative is this one. So the 3 stays up on top. And since 5 has a negative in front of it, it goes on the bottom. Or conversely, if it's on the bottom, then only move this one since it's negative. Leave the 3 alone, don't do anything with it. Once you move it to the other side of the dividing line, drop the negative. Okay, so if we got something like this. Only move the ones that have a negative. So that one has a negative, it's on top, it goes to the bottom. Just drop the negative. That one has a positive, it stays there. This one has a negative, so it goes up on top now, drop the negative. All right, let's look at some examples here. 9 to the power 1/2. 9 is made up of 3 times 3, so it's 3 squared to the power 1/2. So 2 over 1 times 1 over 2. The 2's cancel. So the answer is 3. (16 1/4). 16 is made up of 4 times 4, 2, 2, 2, 2. So 16 is made up of 2 to the 4th 2's. Multiply the exponents. So we have 4 over 1 times 1 over 4. The 4's cancel. So the answer is 2. Now, what if we had that? Well, that's the same as 16 1/4 times 5. 16 to the power 1/4 to the 5th. We just did 16 to the 1/4 power. That equals 2. So 2 to the 5th is 2 times 2 is 4, times 2 is 8, 16, 32. So that one equals 32. But now 16 is negative. Simply because the 16 is negative. Remember order of operations. This is multiplied, that's exponents. So we have to do the exponent first. 16 to the 1/4, we said it was 2. So the answer is negative 2 because the negative's out in front. (16 to the power negative 1/4). Since the exponent is negative and the 16 isn't, so since it's over 1, we move it to the bottom and drop the negative. So 16 to the 1/4 is 2, so the answer is 1/2. All right. End of chapter 7. Hey, everybody. Good luck. If you have any questions, let me know.